I just stumbled upon this research paper and it looks interesting. WaveCoder tries to solve something very interesting. Coding models usually have an issue with the data sets. The reason why there is an issue because there is a lot of low quality data out there. For example, if you go to Stack Overflow, if you search for a particular problem, you might get like hundreds of different answers, and not every answer is a correct one, plus not even every thread is a correct one. Some of the answers are long stale, they don't work because of the version incompatibilities and lot of other issues. So there is a lot of overlap, there is a lot of duplication, there is a lot of issues in the data set, especially when it comes to coding. So what this model did, they have come up with this new concept of code ocean, which is a data set comprising of 20,000 instruction instances across 4 universal code related tasks, which is aimed at augmenting the effectiveness of instruction tuning and improving the generalization ability of fine-tuned model. So after that, they have this WaveCoder, which is a fine-tuned code LLM with widespread and versatile enhanced instruction tuning. I still believe they can improve the language of this paper, because if you read through this and then if you read through this paper and this diagram, then it really becomes quite complicated. I don't think so this is bit that complicated a concept. The concept is great. So let me take a shot on it. So for example, what they have done is they have taken a data set of 6 languages, and then also they have taken 2 million comments code pairs, and the dataset by the way is code searchnet, and then they have done some basic filtering, and then around after that filtering, out of that 2 million only 1.2 million comment code pair remained. After that they performed the usual stuff of embeddings on each pair, and then they found out that the 20,000 most important samples were the relevant ones. So using k-center greedy unsupervised clustering, which is meant to maximize diversity in those 20k samples. Or if you want me to put it simply, what they did was they found a small and focused set of samples that each individually contribute as much new knowledge as possible. Okay. Now, once they had it, they created a data set, as I mentioned earlier, for instruction tuning, and then the if you look at this diagram, what is happening here is that we have a generator and a discriminator. The notion here is that you try to generate high quality instruction data with GPT-4 by using the context in the comments from the comment code samples, and then the discriminator is then used to judge the output on several quality metrics. The discriminator not only judges a sample as good bad, but additionally writes a short analysis on each rule. The resulting tuning dataset therefore not only contains good samples but also bad samples that the LLM can learn from, which context and explanations about what is good about it. So, and then they have fine-tuned on various models, compared their performance using a few benchmarks. For example, on the human eval explain and human eval fix, which the benchmark they used, the performance of the model was quite good, and it was able to fix the broken code pretty rapidly. So I don't think, well, on theory it looks great. I mean, if you go through this paper and this diagram, and then there are also some benchmarking done, and also how much programming languages they have used. It is Python heavy, by the way, and these are the prompts they have used. This looks great, but I have searched it on Hugging Face. I don't see any weights. I don't see any models card and other information. I don't have any quantized version. I don't have any code to play around with. So, of course, we cannot believe what they're saying until we see it in action. So, great idea, but we need to see the execution, and it would be great to have it in quantized GTUF format, and then we will play around with it. And once I get it, if they do it, then I will make another video and show you how you can locally install it and then play around with it, and we'll see if what they are saying is correct. That's it, guys. I hope that you enjoyed it. If you have any comments or thoughts, let me know. Or if I have missed anything around their weights, or if you know that if the code is available or any quantized version is available, please put it in the comments, and I'll be happy to make another video. Please subscribe to the channel if you're not already and share it among your network, as that always helps. Thank you very much.